identify the sample using these 3 food tests, which is what we did before in the lab. Then the solution of Cester blue, purple, and white emulsion. If it's blue in Benedict means okay, no reducing sugar. Right? No reducing sugar. If it is purple with purette means there are proteins present. If it's white emulsion means there's lipids present. So now the trouble is, out of these 4 things, which is what? Okay, let's look at W. What do you think W is? Okay, for those that say protein, how do you tell it's a protein? Okay, we can see, what would you say? NC. Okay, so there's an amino group. Is there? Yeah, there's an amino group. And the other end is a carboxyl group. Or you can look at all the peptide bonds present. So if you want to, you can circle all these peptide bonds that are present. Okay, so it's going to be a protein. Or rather, it's just a dipeptide. It's just 2 amino acids together. Sorry, 3 amino acids together since there are 2 peptide bonds. What is X? X looks like some sort of a carbohydrate, right? But not a sugar. It is a carbohydrate. It's really long. You see the 300 to 600 means it's really long. So that's not a reducing sugar. Let's look at Y. Y is a lipid. It is a triglyceride. How you tell? You can see all the ester linkages here. 1, 2, 3. Triglyceride. Last one over here. This is some form of a sugar. So, what would be the best? It seems like W, Y, Z may be the best answer. Yeah? First one is A. What is A? W, X, Y. W, X, Y. Okay, I do not think it's A. Okay, I think the answer should be C. Yeah? Sorry? Oh, wait, there's no sugar, right? Okay, sorry. No sugar. Right, so there's no sugar. Thank you. Okay, if there's no sugar, then we should be choosing the one that is a carbohydrate, which is X. So it is WXY. Wow, shucks, I also got K. Okay, since Z is a sugar, it should have turned brick, the solution brick. Thank you. So WXY. Okay? Alright, can you do yourself a favor? As we go through the questions, if your notes prepare you for this particular question, meaning to say you had the information in your notes, can you give yourself a tick in your notes somewhere so that you know that hey, this part actually is it can be assessed now. Sometimes we write a lot of things in our notes, but some are not very going to come in very useful. Okay? So if it came in useful, go and put a tick somewhere. Later on, if you encounter questions that your notes need to prepare you for, can you start that question? Then you can put the information that you learned into your notes. So that next time you study your notes, you are more prepared. Those that you did not prepare for, you're going to start it, and you can improve your notes from there. Let's look at, yes. Right, carbohydrates are made of glucose. Okay, so in order for the test, the Benedict's test to work, it requires all the hydroxyl groups to be free so that you can test for it. Okay? But when it's used up inside a glycosidic bond to form a carbohydrate, these glycosidic bonds, these hydroxyl groups aren't as available. Okay, the ones at the sites to test for. So unless we digest X, we won't be able to detect all the glucose that's present. Next, which statement best describes how the structure of cellulose is suited to its function? What's your answer? Boy, yeah. Is it boy? Dog. Dog, okay. Cellulose has an unbranched structure, yeah, and cross links between chains, yeah, to provide structural purpose. Okay, seems fair? 2D. Alright. Next, let's look at 3. These are the steps that supposedly this person did to for burette test. He added water and added copper sulfate. How can this be improved? What is your answer? Boil. Oh, boil. Okay. Normally we don't just add water, right? You add sodium hydroxide first. Okay. What's the purpose of sodium hydroxide? It's just so that it's just out of the syllabus, but for your information. Sodium hydroxide denatures the protein. We learn the word denature. Denatures the protein, uncoils it, so that copper sulfate can actually detect all the peptide bonds. So that's its function. Okay, if you don't use sodium hydroxide, you cannot uncoil all the proteins to detect the peptide bonds. Okay, so answer is boy. Next, let's go to question 4. Hey, sorry, if you chose some other answer, but it doesn't quite make sense, you raise it out to me, okay? Yeah. Anyone chose alternative answers that you like to clarify? No? Okay, go to 4. The diagram shows an amino acid, arginine, which correctly identifies the various things ordered in alpha carbon. Okay, where is the carboxyl group? The carboxyl group should be number 3. Yeah? So we rule out option C and D. Where is the amino group? The amino group should be number 4. Where is the variable side chain on the R group? It should be the entire thing number 1. So where is the alpha carbon? The alpha carbon, if you did not label it, is this fellow over here. Okay, this is a skeleton, so we did not draw all the carbons. Okay, so this point over here should be a carbon. You may be thinking, hey, then what's the hydrogen? Okay, if you ever see something like this, right? Over here is a carbon, then there's one more hydrogen here. Right? And then below is bonded to the NH3+, and here is the OOH. Over here is actually a carbon, then here is the R group. So did your notes prepare you for this? Okay, so let me tell you, very rarely will we present you an amino acid where the amino group is just nice on the left, carboxyl group on the right. We like to mess around with you and then we will like scramble up the order. Okay? Next, question 5. What strand has this? What is the sequence of the complementary strand? What is your answer? What's your answer? Boy? Okay. So, we know that the strands need to be anti-parallel. One runs in 3 to 5, the other must be 5 to 3. So everything is 5 to 3 here. Okay. What should pair with G? Something that has C. What should pair with A? Something that has T. So, looks like B looks like the best answer. Question 5. B. Last one. Okay, why not D? Right? We know that DNA doesn't contain uracil, only mRNA. So it cannot be D either. Okay, even though it's very similar. Last one. For DNA to be effective in storing information, it must be stable. The following features of the DNA as such. Which feature makes it effective for storing genetic information? Okay, what's useful for stability? The hydrogen bonds between the bases, that's important so that the two strands can be together. Number two, covalently bonded sugar phosphate backbones. That's what helps all the nucleotides join together stable, in a stable way. Last one, specific sequence of bases. That's what will determine the information. Yeah? Depending on how I put the A, T, C, G, it's like a sentence. Different combination will result in a different sentence, different information. So I believe the best answer will be D. A, is it D? Sorry, wrong. Flip A. Stability is for 1 and 2. Able to carry information will be number 3. So A should be the best answer. How do you do for MCQ? Pass? 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 Next. Have you seen this before? Do you know what these are? Okay, what's the molecule on the left? It's a triglyceride. Okay, molecule on the left is a triglyceride. Molecule, hey, it's even told you, it's a triglyceride, phospholipid. Okay, never mind. So, they ask you to compare and contrast these two things. Okay? There are a lot of things you can compare. I'm going to show you some of the things you can compare. We provided a table for you to write down the structure that you're comparing and then what you compare. So we only want you to compare 3 things. And we provided a lot of variations. Okay, so these are all the things you can compare. We try our best to think from your perspective, the things you can compare. Any 3 will do. So I hope you did not leave blank and you really squeeze out some differences. Yes, Hoya?
Like the double bond, can I say saturated?
Oh, okay. Where?
Like I just read if saturated fatty acid change up.
Okay, so if you say saturated rather than no double bond, right? I'm okay with that. Same meaning. So we provided 2 variations. Some of you may have wanted to say double bonds. Some may have wanted to say saturation level. They both would have been okay. Yes? Oh, presence of a king. In sure, I think that's fair. Presence of a king. Anything else? The one that is unsaturated as the king, right? The one with double bond. Yeah? Okay, so any one of these 3 would have sufficed. I think the key here would be, can you check your notes? Did you compare and contrast phospholipids as well as the triglyceride? This is a chapter on lipids. Okay? So if you found this question difficult, you star it, then you check your notes. You compare and contrast triglyceride, and phospholipid. If not, maybe it's something you want to touch up your notes for. Yes? Hydrophobic, eh? Oh, so it's just hydrophobic. Anything else? No? Okay, then let's go to the next one. What was the next one? Oh, they ask you to identify the protein structure. Yeah? Okay, so in class, I've been providing you as many opportunities possible. I keep showing you Google images of proteins, and we practice, right? And we agree in our lesson that all proteins are primary structure. So that one you cannot escape. So you try to back that one up. Number 2, are there secondary structures here? And what kind? Alpha helix. So you go and back that one also. Is there a tertiary structure here? Yes. Where do you see beta? Where? Here? 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 Where? Oh, this one. Okay. Is it a beta? How is it a beta? Fair enough. Okay, but to be able to observe a beta, usually a beta will look like what you normally see, like a ribbon, then got an arrow going one way, then another arrow going another way, or it could be the same way, but you need a few to really be considered a beta. I don't know what that is. Okay, but there's nothing parallel to each other, so I wouldn't consider that beta Peter sheet. Is that a tertiary structure? Yeah. As long as you see it's like one lump huddled together, that's a tertiary structure. So, is that a quaternary structure? That's a tougher one. Okay, so I teach you one way you can tell whether there is a quaternary structure is, if it's a quaternary structure, you need more than one polypeptide present, right? Every polypeptide should have two ends, one end, two ends. So if I have two polypeptides together, I should be able to spot four separate ends. One end over here belonging to one polypeptide, another end over here, another end over here belonging to another polypeptide. So that's another way to spot the presence of more than one polypeptide. Over here, I can only spot two ends. Okay, so yes.
Different color.
No, it's not a different color. Oh, it's different shades. Oh, I see. Now I see what you're saying. Okay, fair enough. Okay, look. Fine. Okay, fair enough. I feel like if you want to go by the argument, then I guess it looks like there are two different polypeptides because there are two different colors. Yes? Okay, so if you want to go by the argument, okay, fair enough. Okay, then I thought my exam I better pay attention in the colors that I said. Okay, but for this particular protein, if I want to go back to its source, actually it is just a tertiary because there's only two ends. It's just one polypeptide. Okay? So how would we grade you for this particular question? Number one, you will describe the primary structure. So you must describe each level. First one, the words you should have, your keyword to be primary structure. Then you must describe what a primary structure is. Different numbers, type, sequence, held together by peptide bonds. I'm going to highlight in blue everything related to bonds or interactions. So secondary structure, you will say that there's a secondary structure. You will say that there are alpha helix present. What are the bonds holding that structure? You will describe it as hydrogen bonds. At the tertiary level, the bonds involved are these. Bonds involved are these four bonds. And then you would say that there's a tertiary structure. You can say that there's a three-dimensional shape. So we will have awarded 1 mark if you correctly describe all the points in blue, all the levels of holding. number 4, I say again, number 4, if you correctly describe all the levels of folding, the bonds that are involved, then you will get a mark. If for each point number 1 to 3, you only describe the points in yellow, then you'll get 1 mark, 1 mark, 1 mark. If you mention all the bonds involved, then you'll get the 4th level of mark. Yes? When? Oh, sorry. When they say reject, means reject if the student says that both are present. Oh. Yeah. Can you check your notes? For proteins, do you describe each level in this way? Everything I highlight in yellow and blue are the vocabulary you should use. The English in between is a little bit more flexible. Okay, everything highlighted, I say again, are the vocabulary you should be using. In between, how you structure in a sentence, that's a little bit more flexible. And that's where I will come in to see if it makes sense, the way you string them together. For those that are a little bit more free, look at your notes. Do you describe your notes in this way when you're describing each level of structure? I guarantee you 100%, okay, maybe not, 95%, we will definitely ask you again the levels of structure of a protein. There's no way you will escape this. Your topical exercise, we had a question like that. Yeah? And now your quiz also something like that. Okay, so for the chapter of proteins, there's no other way I can assess you, your understanding. The only way I can assess your understanding is I plot you a new protein. So actually I like to set questions for this chapter, because all I have to do is find a new protein and plot them. Okay, but now I know, I also need to grayscale everything the same shape. Yeah, put just back. Okay, we have around 3 more minutes. Tomorrow's lesson, I will go through the last question. Yeah? Is there one more question? Okay, tomorrow's lesson, I'll go through the last question, then I'll collect your paper. Thank you. Can you help me press stop?